Hello everyone, welcome to our YouTube channel Enthralling SudokuManiacs. Hope you all been doing good. I'm Kishore and today we'll solve an anti-night Sudoku. Now this Sudoku is taken from the blog Life in Sudoku authored by Gaurav Jain. I will add the link to his blog under the description. Now Gaurav has posted some absolutely brilliant Sudokus in his blog, so do check out his blog for more such Sudokus. With that, we'll move on to the rules of the Sudoku. Now this Sudoku, in addition to classic Sudoku rules, there is some other constraint, that is an anti-night constraint. So digits which are a night's move apart cannot contain the same digit. So for example, let's take this 2. Now this 2, okay, this is a bad example. I'll take this 9. So this 9 cannot be present at a knight's move from itself. So it cannot be here. Now a knight's move is defined by 2 moves in any direction followed by 1 move in the perpendicular direction. So we can go 2 moves in this direction, for example, and in the perpendicular direction we can go 1 move. So a 9 cannot be here. Similarly, a 9 cannot be here. You can go 2 moves in this direction and 1 move in the perpendicular direction. So it cannot be here. It's similar to a chess knight. If you are aware of how a chess knight moves, this should be easy to follow for you. So a 9 cannot be in this cell, in this cell, in this cell, in this cell and this cell. So those are the rules. With that, we'll solve this Sudoku. Okay, I will pencil mark 5 possibilities in box 6. It can only be in these 2 cells. And in box 2, because of the 9 here, a 9 is removed from this cell as well. So a 9 should be here. And in column 4, we can see that 9 can only be in this cell because it is forced out of this cell. It is at a knight's move away from this 9, so 9 can only be in this cell. And now in row 5, 9 can only be in this cell. It is at a knight's move from this cell, so 9 is forced out of this cell, so 9 would be here. And similarly in column 2, using classic rules and the help of these 2 9s, 9 is eliminated from this cell because it's at a knight's move from this cell, and it is removed from this cell because of this 9, and so 9 should be here. And in row 7 we can force the remaining 9. 9 is eliminated from this cell because it's at a knight's move from this 9, and the final 9 can be placed here. Now this would be only a 2 or a 4, rest of the digits aren't possible. And this would be a 2, 4 or 7, and this would be a 2 or 4 because it is at a knight's move from 7. We can eliminate 7 from row 9 column 2. So 7 has only one possibility in row 9 and it would be here. And now 7 can be pencil marked here. Right. This 7 is a little powerful. As you can see, it removes all these 5 cells. These 2 cells are at a knight's move from this 7, and these 3 cells, using classic rules, you can eliminate. So 7 can only be in this cell, and that forces 7 in box 2 to be here because this is at a knight's move from 7, and that forces the 7 here and a 7 to be in one of these 2 cells. And using classic rules, 7 would be here in box 4, and in column 3 7 has only one possibility, which would be here. Now we can notate the left out digits. This would be 1 or 3, this would be 3 or 6 because 1 is at a knight's move from this cell, and this would be a 1 or a 6. Column 4 can be notated now. The left out digits are 3, 4 and 8, so this would be a 4 or 8. This would be a 3 or 4 because 8 is at a knight's move, and this would be a 3, 4 or 8. And column 6 can be notated now because it has 6 filled digits. The left out digits are 1, 4 and 8 in column 6. So this can be notated now to be 5, 4, 8. So this will be a 5 now using classic rules. This would be a 1, 4 or 8. Sorry, this would be a 1, 4 or 8, and this would be a 1, 4 or 8. And 1 in column 7 can only be in these two cells. 6 in row 3 can only be in these two cells. This would be 4 or 8. Rest of the digits are not possible. Okay, now let's have a look at column 7 closely. 5, 7 and 9 and 2 and 6 aren't possible, and 1 is in that box, so 1 is also not possible. So the left out digits are 3, 4 and 8. Now 8 is also not possible if you look closely, because if this cell were an 8, then box 8 cannot have 8 in any cell, because it will remove these 3 cells, and because this cell is at a knight's move from this cell, so 8 can't be here as well, and 8 is already removed from this cell. So we can remove an 8 from this cell. So now we have a 3-4 pair which removes the 4 from this cell. So this would be a 1, 2 or 8. Okay, again we have a lovely deduction here. Row 8 column 5, that is this cell, cannot be a 3 or a 4, because let's say if this cell were a 3. Now 3 is removed from this cell and 3 is removed from this cell as well, which is not possible, because that will force 4 to be in both of these cells. And if it were a 4, for example, 4 is removed from this cell and 4 is removed from this cell as well. So 4 is also not possible in row 8 column 5. So this can only be a 1, 2 or 8, but 2 is at a knight's move from this cell, so this will be a 1 or an 8. So we have 1, 8 pair now, so this will be a 2. This should be a 4, this is a 3, this is a 4, this is a 2. We can remove the 3 from this cell. And using classic rules, 4 can only be here in this box. Now 5 can only be in this box, because this is at a knight's move from row 5 column 3, so 5 will be here. And 5 can only be here in column 2, because this is at a knight's move from this 5, and 5 cannot be here, and 5 is in columns 1 and 3, so 5 will be forced here. And 5 can be notated here in box 3. So this will be a 1 or a 6. This should be a 6 or 8. Along row 7, if you look at, you will get those digits. This is going to be a 3 or 8 along column 7. This is going to be a 1 or 8, because it can't have a 3. This is at a knight's move from this 3, and this will be a 1, 3 or 8. Okay, if we look at this cell, 2, 4, 5, 7 and 9 can't be there, and so can't 1 and 3 be, because they are at a knight's move from row 2 column 4 and row 2 column 6, so these cells cannot have a 1 or a 3, it can only be a 6 or 8. And also a 3 cannot be in row 5 column 5. Now the only place left for 3 in box 5 is in row 6 and column 5. Okay, now this is again a beautiful deduction. Row 5 column 5 cannot have a 1 or 8, because if it were a 1, it will remove the 1 from this cell, which is at a knight's move from this cell, and it will remove the 1 from here. And similar idea for 8. So this cell cannot be a 1 or 8. So this is going to be only a 6. I'm sorry. This is only a 6. So this would be an 8. This is a 1. This is 8. So this is an 8. This is a 4. This is a 4, and this is a 1. And using classic rules, we can fill box 7 now. So this can be filled now, and this will be 2 or a 3, because 8 is at knight's move from this cell. This will be a 2, 3 or 8. And column 3 can be filled now. This is a 3, because 6 is in that column, and this will be a 1. So 1 can be removed from this cell. Now we have 3, 8 pair in column 7, so this will be a 1. And because 4 and 5 or in box 4. 4 and 5 can only be here along row 4, because it has 1, 3, 7, 8 and 9, and 4, 5 has to be in that row, so 4 and 5 would be locked in these two cells. So this cell will be a 2, using classic rules. 2 is in column 2, so this cell will be a 2, this will be a 6, and that forces this cell to be a 6, and along column 1 we can place the 1 now, which immediately gives us this 7 and an 8 here, and this will be a 7 now along column 1, this will be an 8, this will be a 4, and this will be a 3, all classic rules. And along row 1 we can fill the remaining digits. Box 3 can be filled now. Okay, column 7 has only 8 left, and 2 and 3 has to be in these two cells. Row 5 has 2 and 3 left, but this cell is at a knight's move from this 2, so this would be a 3 and this would be a 2, which forces this to be a 2 and this to be a 3, and now the left out digits are 6 and 8, and that forces the 6 and the 8 to be here. So this had a cute anti-knight solve. I hope you all enjoyed watching this video. If you like this video, please remember to subscribe to the channel for more such videos from us. Hope to see you soon.